Welcome to this comprehensive guide on finding the area of a triangle. Today, we'll master one of the most fundamental concepts in geometry that you'll use throughout your mathematical journey. The area of a triangle represents the amount of space enclosed within its three sides. Think of it as measuring how much surface the triangle covers. The fundamental formula for triangle area is area equals 1/2 times base times height. This elegant formula works for any triangle, regardless of its shape or size. Understanding triangle area is essential in many real-world applications. From land surveyors calculating property boundaries to architects designing buildings, this formula is used daily in professional fields. In the following sections, we'll break down each component of this formula, work through practical examples, and ensure you can confidently apply this knowledge to solve any triangle area problem. Now that we understand what triangle area represents, we need to identify the two key components we use to calculate it: the base and the height. The base of a triangle is simply any side of the triangle. This is an important point. We can choose any of the three sides to be our base. Here's a triangle. Notice that it has three sides. Each of these sides could potentially serve as our base. For now, let's choose this bottom side as our base. I'll highlight it in amber to make it clear. The height is the perpendicular distance from the opposite vertex to the base. The key word here is perpendicular. This means the height must form a right angle with the base. Here's the height of our triangle. Notice how it drops straight down from the top vertex and meets the base at a perfect right angle. This right angle is crucial. The height must always be perpendicular to the base. Now here's something important to understand. We can choose any side as our base, and each choice will give us a different height. Let me show you what happens when we choose a different side as our base. Now I'll choose this left side as our base. Watch what happens to the height. With our new base, we get a completely different height. But notice, it still forms a perfect right angle with the base. The height is always perpendicular, no matter which side we choose as the base. Let me clear this and summarize the key points you need to remember about base and height. Here are the essential points about base and height that you must understand before we move on to the area formula. First, the base can be any side of the triangle. You have complete freedom in choosing which side to use as your base. Second, the height is the perpendicular distance from the opposite vertex to your chosen base. Third, this is crucial. The height must always form a 90-degree angle with the base. If it's not perpendicular, it's not the height. Fourth, when you choose different sides as your base, you'll get different heights, but the area of the triangle will always be the same. Let me show you one more example with a right triangle to make this crystal clear. In a right triangle, we can easily see the base and height relationship. The two sides that form the right angle can serve as base and height for each other. If we choose the horizontal side as our base, then the vertical side becomes our height. They're already perpendicular because this is a right triangle. Understanding base and height is fundamental to calculating triangle area. In the next section, we'll see exactly how these two measurements combine in the area formula. Now we arrive at the fundamental formula for finding the area of any triangle. The area equals 1/2 times the base times the height. But why does this formula work? Let's explore the mathematical reasoning behind it. To understand why this formula works, we start with a triangle. Here we have our triangle with its base labeled as B and its height labeled as H. The height is always the perpendicular distance from the opposite vertex to the base. Now, here's the key insight. If we take our triangle and create an identical copy, we can arrange these two triangles to form a parallelogram. Watch as I add the second triangle to complete this parallelogram. This parallelogram has the same base B and the same height H as our original triangle. The area of any parallelogram equals base times height. This is a fundamental geometric fact. Now comes the crucial observation. Our triangle occupies exactly half of this parallelogram. The parallelogram is made up of two identical triangles. Therefore, the area of one triangle must be exactly half the area of the parallelogram. Since the triangle is exactly half of the parallelogram, we can write that the triangle area equals 1/2 times the parallelogram area. We know that the parallelogram area equals base times height, so we substitute this into our equation. This simplifies to our triangle area formula, A equals 1/2 times B times H. This is why the formula works. Every triangle is exactly half of a parallelogram with the same base and height. Now that we understand why the formula works, let's examine each component. The 1/2 tells us to take half because triangles are half of parallelograms. The B represents the base, which can be any side of the triangle. The H represents the height, which is always the perpendicular distance from the base to the opposite vertex. This formula is universal. It works for all triangles regardless of their shape or size. Whether you have a right triangle, an obtuse triangle, or an acute triangle, this formula will always give you the correct area. The key is correctly identifying the base and measuring the perpendicular height. Now let's work through our first example to see how the triangle area formula works in practice. This will be a straightforward calculation that demonstrates each step clearly. We have a triangle where the base measures 10 centimeters and the height measures 5 centimeters. Our goal is to find the area of this triangle using the formula we learned. First, let me draw the triangle so we can visualize what we're working with. I'll create a triangle and clearly mark the base and height. Now I'll highlight the base and height. The base is the horizontal line at the bottom, measuring 10 centimeters. The height is the perpendicular distance from the top vertex down to the base, measuring 5 centimeters. Let me label these measurements clearly. The base is 10 centimeters and the height is 5 centimeters. Step 1. We start with our triangle area formula. Area equals 1/2 times base times height. Step 2. Now we substitute our known values. We replace B with 10 centimeters and H with 5 centimeters. Step 3. First, we multiply the base times the height. 10 centimeters times 5 centimeters equals 50 square centimeters. Step 4. Finally, we apply the 1/2 factor. We can think of this as dividing 50 by 2, which gives us 25 square centimeters. So the area of our triangle is 25 square centimeters. This means that if we were to cover this triangle with unit squares, each measuring 1 centimeter by 1 centimeter, we would need exactly 25 of them. Notice how we followed each step methodically. We identified our given values, applied the formula, performed the multiplication, and then applied the 1/2 factor. This systematic approach ensures we get the correct answer every time. Now we'll work with a more challenging triangle orientation. This is an obtuse triangle where one of the angles is greater than 90 degrees. Notice something important here. The height of this triangle actually falls outside the triangle itself. First, we need to identify our base. I'll choose the bottom side of the triangle as our base, which measures 8 meters. Remember, we can choose any side as the base. The formula will work the same way. Now here's the key concept. The height is always the perpendicular distance from the opposite vertex to the base. In this obtuse triangle, when we draw the perpendicular line from the top vertex down to the base, it actually extends outside the triangle. This is perfectly normal, and the formula still applies. The height measures 6 meters. Even though this perpendicular line falls outside our triangle, it's still the correct height to use in our area formula. This is a common source of confusion. But remember, height is always perpendicular distance, regardless of where it falls. Now we'll apply our area formula. We use the same formula as always. Area equals 1/2 times base times height. Step 1, we substitute our known values into the formula. Base equals 8 meters and height equals 6 meters. Step 2, we multiply the base and height first. 8 meters times 6 meters equals 48 square meters. Step 3, finally, we multiply by 1/2. 1/2 times 48 square meters equals 24 square meters. This is our final answer. The area of this obtuse triangle is 24 square meters. Notice that even though the height fell outside the triangle, we used exactly the same process. The key insight is that height is always measured perpendicular to the base, and this perpendicular distance gives us the correct area calculation regardless of the triangle's orientation. Now we'll work through our third example, which involves a right-angled triangle. This type of triangle has special properties that make finding the area even more straightforward. Here we have a right-angled triangle. The two sides that form the right angle are 3 inches and 4 inches long. Notice the small square symbol that indicates the 90-degree angle. Right-angled triangles are special because the two sides that form the right angle are already perpendicular to each other. This means we can use them directly as the base and height in our area formula without needing to find the height separately. Watch as I highlight the base and height. The horizontal side of 3 inches serves as our base, and the vertical side of 4 inches serves as our height. Now let's solve this step by step. First, we write down our area formula for triangles. Step 2, we substitute our known values. The base is 3 inches and the height is 4 inches. Step 3, we multiply 3 times 4 to get 12 square inches. Finally, we divide 12 by 2 to get our answer, 6 square inches. This result makes perfect sense. We were able to use the two perpendicular sides directly as base and height without any additional calculations. The area of 6 square inches is exactly half of the rectangle that would be formed by these two sides. Right-angled triangles are particularly useful in real-world applications because their perpendicular sides make area calculations straightforward and eliminate the need for complex height measurements. Now that we've worked through several examples, it's important to discuss the most common mistakes students make when calculating triangle area and share some helpful tips to ensure accuracy. The most frequent error is using a slanted side of the triangle as the height. Remember, height must always be perpendicular to the base. Here's the correct approach. The height must form a perfect right angle with the base. Notice how we drop a perpendicular line from the vertex down to the base. Always remember, if the height line doesn't form a 90-degree angle with the base, it's not the correct height measurement. Another common mistake is forgetting that area is always measured in square units. When your base and height are in centimeters, your area must be in square centimeters. Notice how the correct answer includes the square units. This is crucial because area represents two-dimensional space, which is why we use squared units. The third common mistake is forgetting the 1/2 factor in the triangle area formula. Remember, a triangle's area is exactly half the area of a rectangle with the same base and height. Without the half factor, you're calculating the area of the entire rectangle, not just the triangle. This would give you double the correct answer. Here are 4 essential tips to help you avoid these common mistakes and calculate triangle areas accurately every time. First, always verify that your height measurement is truly perpendicular to the base. Use a right angle symbol or check that it forms a 90-degree angle. Second, double-check your arithmetic, especially that you've included the 1/2 factor. This is the most commonly forgotten part of the formula. Third, always include square units in your final answer. Area is two-dimensional, so your units must be squared. Finally, always estimate whether your answer seems reasonable. If you're calculating the area of a small triangle, you shouldn't get a huge number. Remember this fundamental formula. Ensure your height is perpendicular, include your square units, and you'll calculate triangle areas correctly every time. Now that we've completed our journey through triangle area calculations, it's time to recap the essential concepts we've covered together. The fundamental formula for finding the area of any triangle is 1/2 times base times height. This simple yet powerful formula is the foundation of triangle geometry. Throughout this video, we discovered several key principles that make triangle area calculations both reliable and versatile. Understanding triangle area isn't just academic. It has practical applications across many fields, from architecture and engineering to art and land surveying. Mastering this fundamental concept opens doors to more advanced geometric calculations and real-world problem solving. The triangle area formula is truly a building block for mathematical success. If this video helped clarify triangle area calculations for you, please give it a thumbs up and let me know in the comments what other geometry topics you'd like to explore. Don't forget to subscribe for more step-by-step math tutorials that make learning both clear and enjoyable.